Hi, my name is Charlotte O'Brien,
I'm Spencer Torres.
and we're going to be talking about temperature inversions and how they connect to pollution. Okay. Normally what we experience is a unstable atmosphere, and within that unstable atmosphere is convection. And how convection works is when the sun rays heat up the air on the Earth's surface, that hot air rises, and then it cools adiabatically as it increases in altitude throughout the atmosphere. And once it becomes cold air, it sinks back down to the surface to Earth's surface, and then gets heated up again, and it just creates a really continuous cycle of convection. Okay, so these are the layers of the atmosphere. And normally, so we're going to be talking about the troposphere. And in the troposphere, it's a stable atmosphere and not an unstable atmosphere. So within that stable atmosphere, temperature inversions happen. And so what that means is there's no motivation for convection. There's not a lot of mixing depth within that. So what happens is the cold air stays at the top of the sky, and the hot air stays at the top of the sky, and the cold air creates a very thick layer on the surface of the Earth. And this is very dangerous because that cold air can mix and combine with the pollution to create a pollution cap. And this happens commonly in cities like Beijing, China, and Delhi, India. So it's just very dangerous because it greatly reduces the visibility when driving and just walking around day to day. So here's a picture of a stable atmosphere where temperature inversions happen. So this is within the troposphere. So as you can see, you have that cold layer combined with the pollution of the factories. And then you have that warm layer up above in the troposphere. And then, in the unstable atmosphere, you can see that the warm air and the cold air rotates in a convection circle. Okay, here.
So you may be wondering, why would a temperature inversion even happen? An example of one time a temperature inversion may happen in the atmosphere is when a cold air mass is moving in to a warmer air mass. So generally, air will only rise if it is warmer than the air around it, but with a cold air mass, it forces some air up, so now there's a layer of warmer air, and this means that air that wants to rise up cannot continue rising up because there's now a layer of warm air, and since it's not as warm as that warm air, it causes a cap on the atmosphere so that things can't keep rising when they want to. As you can see here, there's this is a unstable atmosphere, where air can continue rising until it's no longer warmer than the air around it. But in a temperature inversion, there is a warmer layer right here. So air that wants to keep rising hits an unexpected layer of warm air and can't continue rising because it's not warmer than the air around it. And this creates a problem, as Charlotte said, with pollution because pollution cannot rise throughout the atmosphere. It gets trapped by the surface, which can create a lot of problems with breathing and in cities where pollution is a big problem like Beijing. So, as you can see here, this is just a photo of the temperature inversion. As you can see, the pollution is trapped right above the skyscrapers, which creates a big problem for plants and animals as well as humans who can get sick from breathing in it.
So, many of you ask, what is the solution to this? Well, the solution to pollution is dilution. So what that means basically is in order for the pollution cap to fully dissipate, you have to have some turbulence to come into that stable atmosphere and really mix the cold pollution mix together to dilute the air quality so that you can breathe better and that visibility is better. So until wind comes in and acts as turbulence to really dilute the pollution cap, the cap will continue to stay where it is. Okay, I'm Charlotte O'Brien.
And I'm Spencer Torres.
Thank you
for
listening
listening and watching.